Hello and welcome to another free code session. My name is Jason Bach. In this episode, I'm going to be talking about generics and type parameters, specifically types that you can't pass into type parameters. I'll also cover one of the cases in terms of a feature in C# 13 that now allows you to pass in those kinds of types. Before I get to that, I want to spend a little bit of time just talking about generics and what it was like before and after generics were added. Generics wasn't something in .NET until .NET 2.0 or C# 2.0. .NET was released in 2002. .NET 2.0 was released in 2005. So for a while, if you wanted to have a group of items that all were of the same type, you could either use an array or you could use an array list. The problem with using an array list is, sure, I can pass in 33 and 44. I can do a for each on it and print them out. But I can also pass in strings, and I can also pass in GWIDs. These are not integers, but nothing is going to stop me from doing that. So if I wrote some code to try to get the sum of all the values within values, I'm going to get a runtime exception. In fact, you can see here, I print out 33 and 44, but when I try to do that sum, I get an invalid cast exception. And that also shows that when you get the value out of values, it is of type object, and that's why I have to do a cast here. So this has some performance problems because I have to do casting. There's boxing and unboxing with struct values. There's also a lack of type safety. I can put in values that I did not expect of different types, and that's going to cause issues at runtime. People for an array list would create wrappers around it so that they could have a collection that they knew was going to be of a certain type, but then you had to either generate that code or write it by hand, and that was laborious and tedious. In .NET 2.0, generics were added, and I'm sure you've used generics all over the place in your code. The canonical example again is a list, except this time, in using array list, I'm using a list of int. I specify with the type parameter t an int. And so anything in values is always going to be an integer. So if I uncomment these two lines of code, you're going to see that I'm going to get red squiggles in Visual Studio because it's telling me that this is incorrect code. I can't pass in a string and I can't pass in a GWID. So now what I can do is I can use extension methods like sum. Sum will just automatically go through all the values in my values variable and sum them all up for me. I know that everything within values is an integer, so this works. But as a side note, the reason this really works is because sum is actually looking for your collection of items to implement iNumber. A recent change in C# added something called static abstract members and interfaces. We'll come back to that in a little bit. But that feature allows you to define interfaces that specifies that operators must be implemented. And so what sum does is says, as long as you're giving me numbers, I can sum them all up. So I can also have a list of doubles and take that list and sum those up as well. When I run that code, you can see I get 77 and 77.77. So I'm able to reuse code and not have to write that over and over again. Same thing with just a list. I no longer have to write type-safe wrappers. So generics are pretty powerful. Like I said, I'm sure you've used them all the time now in .NET. When I do talks at conferences, I'll mention that there's a feature that you just can't take away from C#. It would be generics. It is so pervasive in the language and in the runtime. There are other things that you can do with generics that were added after the initial release of the feature in 2.0. You can now do co and contra variants. You can use generic attributes if you like. You can put constraints on type parameters, saying I only want to take a class or a struct. So there are things you can do with generics that I'm not going to cover here. Suffice to say, generics allow you to write some very expressive and type-safe code in C#. There are some cases, though, where you can't pass in a type to a type parameter. I'm going to cover those here. You can see that most of this code is commented except down at the bottom, because a new feature in C# allows you to do something with types of a particular kind. Again, I'll get to that in a moment. The ones at the beginning are pretty esoteric and ones that you would never even think of doing in the first place, but I'm just mentioning them for completeness. So we'll go from the extreme case down to a more realistic case. The first one is void. Now you may think, why would I actually want to have a list of voids or anything like that in my code? And you'd be right. There would be no reason to do such a thing. So in the first case, I can't even use the keyword this way, but it's interesting to note that void actually has a type in .NET, and I'll show it to you where it is in code. The site source.net allows you to peruse all of the code that exists within .NET. And if you look, you'll see that yes, there is actually a void type. Doesn't do anything, doesn't have anything within it, and C# does not let you use it in any way, shape, or form. There'd be no reason for you to pass in a void. The only time you use the void keyword is when you signify that a method is not going to return anything. Just to be technical, you can't use void within a type parameter. If you go to this holder type that I'm using here, and I'm going to be using in some other examples as well, you can see that holder just takes a type T. It allows you to pass in an instance of T into the constructor, and then you can access it through a field. This is going to be important when we get to ref structs in a moment. The next case is some special cases. There are 3 keywords within C# that you've probably never used. They are arglist, makeref, and ref type. If you're interested, I'll have links in the description that talk about what these keywords are, but I've never used them in all the time I've been coding in .NET. And I would venture to guess that that's probably the same for you. That said, there are 3 types that get involved when you use arglist, makeref, and ref type. And that is these three types: arg iterator, type reference, and runtime type handle. Now you'll notice that these 2 are not allowed to be passed into T for holder. The third one can. So in fact, if I run this code, you're going to see that, well, nothing bad happens. The thing to notice here is that when I uncomment this code and I hover over these, you'll see that they're ref structs. Okay? And a ref struct can't be passed into a type parameter. But as I've been alluding to before, that's changing in C# 13. Again, these keywords, these types, you probably have never run into before, and you probably never will. But these are some special types that you just can't pass in, other than a runtime type handle, into a type parameter. The next one, pointers. Pointers aren't very common. I don't think I've ever written any code in C# that I needed to use a pointer, but pointers are allowed. So for example, if I uncomment this code and I have an unsafe block here, you'll notice that I can't pass in an int pointer. So that is not allowed. What I can do though is something that isn't the same thing, but it does kind of sort of work. If you look at pointer holder, I'm passing in an int, but I am passing in the address to value. And pointer holder is an unsafe class that constrains T to be unmanaged. And now what I can do is say I can pass in a pointer of type T to the constructor, and I can also get that value through the value property. Of course, if I wanted to pass in a double pointer or a triple pointer, that won't work. So it's not as generic as I would like, but at least I can specify that I want to use a pointer to an int with pointer holder if I would like. So again, pointers aren't allowed, but you can get around it a little bit if you really need to. The next case is static abstract members and interfaces. As I mentioned before, this feature allows you to define operators and interfaces that need to be implemented. You can also define static methods on interfaces that types need to implement. They are not allowed to be passed in, though, to type parameters. So you can see here that if I actually try to pass in an I number of int, that won't work. And if I hover over it, it gives you a message that isn't very helpful. But the end result, if you start digging in, is the fact that C# just doesn't let you do this right now. I have a link in the description that if you really want to dive into the reasons why and why this case is restricted currently in C#, you can do that. But long story short, this isn't allowed right now. It may be in the future, but as of .NET 9, it won't work. The last case that I've been alluding to is ref structs. Now, if I pass in a ref struct to holder here, that doesn't work. And you're going to see that it says may not be a ref struct or type parameter allowing ref structs. So this isn't allowed. But in C# 13, things change. So you'll notice that I have a ref struct holder here, and I also have a ref struct field holder. Both of these are taking a ref struct, a span event, and both of these work. The reason why these work is if I go to the definition of ref struct holder, is that you see I have what's called an anti-constraint. This says where T allows a ref struct. That sounds weird when you first hear the word anti-constraint. But if you think about something like this, where I said where T is unmanaged, that is restricting types of T. In this case, it's allowing certain types for T. So this is a constraint. This is an anti-constraint. Again, a little bit of an odd wording, but it makes sense the more you work with it. And by doing this, you can see that I can pass in a span event for T now, but I don't have a property or really an underlying field of span event. And the reason why is because of the way ref structs work and how you can capture a ref struct in a field and when you can't. Again, I am glossing over the details, but that's not allowed here unless my containing type is also a ref struct. So now I'm not restricted to just passing in a span event into a constructor or into a method where that would be allowed as long as I don't capture that value into a field. If my type is also a ref struct, I can now store that span event or any other ref struct into this value property. This is also why above, when I showed you holder of runtime type handle, that technically works because it's not a ref struct. Our iterator and type reference used to be just structs, and they've changed this now to being a ref struct, and therefore they can't be passed in. But what's going to happen if I would just say, let's do this. Let's take this code and put this down here. And now let's say ref struct holder. That doesn't work either because type reference cannot be used as a type argument. So even though this is a ref struct, these types are forbidden to be passed in to any type of type parameter. So in this episode, I talked about generics, I talked about type parameters and specific types that you can't pass in. If you've used ref structs in the past, in C# 13, you can now use allows ref struct, that anti-constraint, to provide even more expressiveness in your code. Types like the delegate types in .NET, func and action, they've all been updated to allow all of the type parameters to take ref structs if you want. And there are other places within the core types in .NET where this anti-constraint has been added. Check out .NET 9, it's coming out this week. And you can start looking at maybe places in your code where you can take advantage of this new feature. So that's it for this episode. Please subscribe if you haven't already. Thank you for watching. Leave comments and questions below, and I'll see you in the next episode.